Welcome back, everyone. Now we're going to be revising the definition of polyhedrons and surface areas, just in case you've just joined us. And then we're going to be looking at how we can find the surface areas of some other three-dimensional shapes. Let's go to the board. So guys, you can see that we're then going to have a look at triangular prisms, pyramids, spheres and cones, and last but not least, some cylinders. Cool, so just a bit of revision. A polyhedron is a three-dimensional figure with 4 or more flat surfaces. So just a bit of a reminder, this is a 3D shape that we could potentially hold versus a 2D shape which is on a flat surface. Because a polyhedron is a three-dimensional figure, I can calculate the surface area. And the total surface area of a polyhedron can be found by adding together the areas of each face of a polyhedron together. So all of the faces that make up a polyhedron, if I calculate the area of each of those added together, that is my total surface area. So we're first going to look at the surface area of a cylinder. I'm going to pause right there. Luckily, most of us are very familiar with cylinders. We love to have our cool drinks in our cylinders. We know that a cylinder is made up of a circle at the top, a circle at the bottom, and a rectangle that wraps around it. So now we have to calculate the area of the rectangle and the area of the two circles that comprise the cylinder, because when I add those areas together, that is the surface area of a cylinder. Let's go back to the board. So the surface area will be the area of the top circle, the area of the bottom circle, added to the area of the rectangle. So if we look here, I have my top circle and I have my bottom circle. If we think back to what the area is of a circle, we know that it is pi r squared. So if I'm thinking about the surface area of a cylinder, I'm going to have pi r squared plus pi r squared because I have two circles involved. That's going to account for my top circle and my bottom circle. What I need to add is the area of the rectangle that comprises the cylinder. We know that a rectangle will have a regular height. The trick with this is the length of the rectangle. The length of the rectangle is 2 pi r, and you might be asking, well, why is it 2 pi r? If we think about a cylinder, and if you want to watch my hands, we know that a can or a cylinder shape, the rectangle goes around the circle shape. So essentially the length goes around the circumference of the circle. So actually what the length is the circumference of the circle. So let's go back to the board. This is why my length is 2 pi r, because this actual length wraps around the circumference of the circle. So the lengths are each 2 pi r. Cool. So it's pi r squared plus 2 pi r, and I can simplify that a bit neatly, and that will become 2 pi r squared plus 2 pi r. And that is how I find the surface area of a cylinder. Let's go to the next slide. Cool, everybody. So let's now look at the surface area of a rectangular pyramid. Please keep in mind that I know that the base of this pyramid is a rectangle itself. And in order to calculate the surface area of a rectangular pyramid, we have to take the sum of the area of the base and the 4 triangles. So the first part will be the area of my rectangular base, which is my length times my width. And then I'm going to have to add the areas of each of the triangles together. But please make a note we have the height of the triangular, or the rectangular pyramid rather, but each of the triangles that make up the rectangular based pyramid have their own heights. So this triangle will have its own height, and this triangle will have its own height. So in order to calculate the surface area of a rectangular pyramid, I'm going to take the area of the rectangular base, then I'm going to add it with the area of each of the 4 triangles that make up the rest of this pyramid. Great, everyone, let's go to the next slide. Now we're going to look at the surface area of a triangular pyramid. So the main difference with this one, with the previous slide, is my base is now a triangle. It's not a rectangle anymore. So we have the triangle at the bottom, and then the pyramid is then comprised of 3 more triangles. And in order to calculate the surface area of a, sorry, this is supposed to say triangular pyramid, we have to take the sum of the area of the base and the 3 triangles. So I will take the area of the base, then the area of the triangle that comprises each side of the pyramid. Let's go to the next slide. We then can also calculate the surface area of a sphere. The surface area of a sphere is equal to 4 pi r squared. So it's 4 pi times my radius squared. Just a note here, guys, please make sure that you substitute in your radius and you don't substitute in the diameter, because I know that the radius goes from the center towards the circumference, and the diameter is 2 times the radius. So the surface area of a sphere is 4 pi r squared. Next, we are going to look at the surface area of a cone. The surface area of a cone is equal to pi r length plus pi r squared. And the length that this is referring to is the length of the side of the cone. So we'll be substituting in the radius that will be given, as well as the length of the cone, in order to determine the surface area of the cone. Then we are going to lastly look at the surface area of a triangular prism. And the surface area of a triangular prism can be found by finding the sum of the areas of the triangles A and B. So this is referring to the back triangle A and the front triangle B. And we add the 3 rectangles that make up the rest of the triangular prism. So for a triangular prism, you have a triangle on one side and a triangle on the other side. Then you have 3 respective rectangles that comprise the rest of the triangular prism. So in order to calculate the area of the triangular prism, or the surface area of the triangular prism, I need the areas of the 2 triangles and the areas of the 3 rectangles. Wonderful, guys. After the break, we're going to dive into some examples of how we can actually apply these formulas to surface area. See you soon.